Good morning. How's everybody doing? We're all so spread out here today. And I'll have to see who laughs at my jokes more in terms of whether I focus on this side of the room or that side of the room, because there's one person right here in the middle of the room. And so thanks for coming out. Thanks for braving the long walk to get all the way over to like the far corner of the conference center. I guess they don't want developers along with the DBAs as much. Out of curiosity, how many here are DBAs primarily? Okay. How many developers? Okay. So we can have some nice arguments here today. Yes. Right. We're going to be talking about ORM design strategies, and this is going to be generic across multiple ORMs. I'm not in this session going to be talking only about one ORM as compared to another ORM. It's going to be more hopefully generic and multi-purpose across multiple, which means sometimes you have to take with a grain of salt some of the things I'm saying and such. So just getting started off, you've probably seen these slides before. Keep your phone silent, which means I should probably silence mine. Yeah, it's not been the first time that I've probably had an interruption in my presentation with the phones. Okay, so get that, all the stuff that PASS has to offer is the next thing here, and then this slide actually has a little bit of more information on it, my contact information, Twitter alias. I don't put my email address on these, but if any of you want to contact me via email, my email address is jimw@slalom.com, slalom like skiing. And so I actually am a solution architect with Slalom Consulting, or a national consulting firm. We're actually headquartered here in Seattle. I'm out of the Atlanta office, and so if anybody wants to talk to me about consulting, being a consultant, needing consulting experiences, feel free to chat with me afterwards, and that's the end of my sales pitch. I want to talk today about ORMs, how you can better use them and why you need them. What they are is another key part of this. So I have experience. I've been doing development for almost 20 years now in multiple platforms. And so some of what I'm going to say comes from some of that experience. I'm primarily on the .NET side. I'm on Microsoft MVP in developer technologies. Started off my career professionally with Access development. Ooh, yuck, right? But there's some good things to be said for that as well. And so I've learned a lot as I've been going. I've experienced a lot of things. I've seen various customers, what works for them, what doesn't work for them, and some of those areas. So hopefully some of that experience I'll help to share with you guys as we go here today. So I wanted to start off with a little example. This is actually a slide that I wrote about 15 years or 10 years ago, I guess it was. And this is an old way of accessing data. This happened to be .NET with the ADO, ADO.NET, and the ability to have connection, which we have a SQL statement in strings inside of our code that then it gets values and hydrates parameters off of those values as iterating over we've probably all seen code that looks something like this, yes? Now, if you look at this a little deeper, you'll notice that there's some problems with this code. Anybody see any issues on this code? There's no date in the SQL, yeah. So I'm including values in the parameters that I'm trying to get access parameters which I'm not actually putting in there. Back? Okay, on this one, can I have SQL injection? It's a parameterized query, so there's not SQL injection on this one. I'm not only am I try catching the exception, I'm not wrapping it and using, which is sort of the same kind of concept there, and finally. So I'm not disposing of the connection, so I can have a memory hole there. Also, I can have a connection to the database hole as well, right? And keeping that connection open longer than I think I should. Okay, let's see how many of these items that you found. We already mentioned this, because we have the queries in quotes, there's no real compile time checking around, am I actually including? Does the customer's data or table actually have a column called phone, right? We're just trusting the developer knows what they're doing and actually is putting the right thing in there. Because it is parameterized, we are getting SQL injection, we're guarding against SQL injection. We are having our query plan cache, and so we don't have to worry about some of those performance issues that you would have if you were just doing raw SQL inside of these types of things. Also, we have loosely bound arguments. Notice my parameter, back in my query, I said P0, and I'm actually passing a P1. So while this would compile, this would actually fail at runtime, and that's the worst time to get an issue, is when you're getting a runtime exception rather than a compile time exception. Okay. Loosely typed result set, like we mentioned, we are asking for values that aren't actually in the results. But when I request, for example, dr.getString1, is that going to give me the name? Okay, I heard no. No, it's not, because the dr parentheses is a 0-based array, not a 1-based array. So it's actually going to have an off-by-1 error. Right? There are really three hard things about computer software development. One is naming issues. The second one's off-by-1 errors. Didn't laugh at that one, huh? Okay, keep going here. Compiler's not checking and finding that we have issues on these kinds of things. What happens if the date was null and we don't check for null? We're going to get a runtime exception there. We already mentioned the connection string issue, right? Not the connection, but the actual connection object. And so while I wrote this sample 10 years ago, I went on to start on a project about 3 months ago, and I saw the exact same problems in their code, right? And so it would be nice if we had some sort of a tooling that allowed us to abstract away all this plumbing stuff so I don't necessarily make those same mistakes over and over and over again, the careless mistakes, shall we say, and focus more on business value rather than on plumbing, right? And so that's where ORMs come into play. ORM literally is an object relational mapper. So we're combining the objects that developers work with against the relational structures that are in the database, and we're mapping from one to the other. That's all it basically is. So before I go any further, I think it's probably appropriate to address the elephant in the church, which is this is going to be a religious conversation. You are probably not going to agree with something that I'm going to say sometime during this presentation, okay? What I'm going to be talking about is based off of my beliefs and things that I grew up learning, which may differ from what your beliefs are and what you're growing up learning, okay? So I wanted to sort of phrase this conversation so we can be in a safe place that if you don't agree with me, that's fine. Let's have a conversation afterwards. But let's try to work with me and go forward, because I can almost guarantee that I'm going to say something that's each one of you individually are not going to agree with during some time in the presentation. Okay. But if we could, let's not let the dogma get in the way of my karma. Right? Okay, that's the end of my dad jokes. Let's go into some more technical kinds of things. So, ORMs. This is a database conference, SQL Pass. Let's start off on the data side, and then we'll move over to the object side. So we're all familiar with relational structures. We have data models, and the database then has things that are columns and entities, and then we are relating one entity to another entity. If we have multiple collections of things, and we have a relationship between the two of those, and we have foreign keys, right? These are all things that we're probably familiar with. We may have plumbing information that says, have we changed this value when it was last changed? These are things that the developer really doesn't need to care about. That's not necessarily business value, but it's things we need to be able to track to be able to maintain integrity of the data and be able to query that data in a flexible kind of way, right? And so, relational structures are out there. We have a lot of principles around good relational design, normal forms and all those kinds of things. And we build our databases to be optimal from a memory perspective and a performance perspective, and make sure that we can do everything that anybody ever going to want to do out of that. And how many here use your databases as you have one database to represent your entire organization? And so you have that common source of truth, right? And so that's then served by 30, 40 different applications potentially, right? Is anybody here working in a microservices kind of environment where every service has its own database? That's sort of the opposite end of the spectrum, right? And it's become more popular. Now, when you do that, then you have challenges of, well, inevitably, somebody wants to find out information from both of those databases, and then you have heterogeneous joins, and that gets messy as well, right? So how do you manage those kinds of things? We have strategies around those, right? So that's from the database side. The O is the developer side. And so we're going to have the objects which are going to represent in memory the state and behavior of particular pieces of information, right? That's what an object essentially is. It's these in-memory structures that are not only the structure, but also the behavior. Behavior are things like, I want to ship this, right? That's a behavior. I want to validate that this is valid and we can actually save it. That's a behavior. As compared to just, does it have a name, does it have an address, right? Those are going to be your structures themselves. And similar to, from a database perspective, we have certain guidelines and principles, object-oriented principles and guidelines, encapsulation, which is we want to make sure that we're sort of hiding the details of how something works. So if I wanted to change the details of how that works under the covers, I can do that without having to have everybody else change how they're going to implement on top of that. Potentially, I could even change out my entire database without having to change the UI if I've done a proper encapsulation. Anybody actually do that? I mean, everybody says the reason why we want to have all these big object-oriented systems and making the design so efficient is that we can just swap out one database for another. Very rarely does that really happen. And so one of the things you need to consider is, do I need to architect for that in the eventuality that it's never going to happen? Or, where do I put that encapsulation layer, right? So it's an art, not a science, in figuring that out at that point. Composition is the ability to compose various components, have code reuse, have the ability to say, well, if I have a customer and it has an address, right? And I might want to have then an order that has a billing address and a shipping address. An address might be a common kind of thing which we can use across all of those. But does my order derive from, does it have an address or is it an address? And so we have to figure, how do we do the composition and inheritance of those kinds of structures? When we have addresses, well, maybe those addresses behave differently. Maybe the billing address behaves differently from the shipping address, because the billing address we're actually going to send a bill to as compared to the shipping address where we're actually going to have it FedExed there or something like that, right? And so the behavior around those may differ based off of what those kinds of things is. And that's what polymorphism is getting into. Right. And there are a bunch of other principles around. Robert Martin has the solid principles. We want a single responsibility so that if each object is responsible for one thing and doing one thing and one thing only, and if you wanted to do something else and you have another object that does that kind of a thing. Dependency inversion, which is if I have cross-cutting concerns, then I'm going to inject that cross-cutting concern across all of my environments, and I don't have to necessarily rewrite that and recode all of those kinds of things for each one of those. There are a lot of these kind of core principles. And so we now need to take the relational stuff and figure out how do we get that into a object kind of a stuff. Because developers, we understand relations, but when we're actually coding, we're coding against objects. We have state, we want to change that state or transform that state into another state. And as the user's typing in things on a screen in a form, then we're going to rebind maybe into those objects and be able to manipulate that kind of thing and move forward from there. So we have to take our relational structures and translate that into an object structure. And sometimes these object structures don't represent one-to-one, and really, I don't think that they should represent one-to-one exactly what the database looks like, right? So on our object structure, for example, notice in this particular domain, I don't need all of the fields that I had over in my relational structure. If I'm just taking an order, I don't necessarily need to know where's the billing information going to be, where's the shipping information going to be, as they're just still in their shopping cart, right? So maybe I can just focus on, during the shopping process, only the pieces of the customer and the order information that I need for the shopping process, and filter out all the other stuff. Also, I don't need, from an object graph, if I have a customer that has orders and orders have order details, I don't need to necessarily say, what is the foreign key on order details back to orders? I just have an object graph, which I can hydrate, and I can drill right in through the object graph and get the information of the object graph. And then the foreign keys are really implementation details of my relational model, not of my object model, right? And so I can then focus on what is the needs of the business and then allow the plumbing functionality to handle how do we actually persist to that as a separate kind of construct and structure. So there's sort of a parallel between the object and relational side of things. Your database, we have applications, schemas, we have namespaces, tables, we have classes, all the way down to columns and properties, right? There's sort of a relationship between the two of these kinds of things. So that sort of gets back to where we have from the objects and the relational. Now, how do we do the translation between the two of those? And that's where the M comes in mapping, right? So we need to figure out how do we get from one construct to the other. And there are lots of different ways of doing that. I'm not going to go specifically into an individual ORM here today. I'll show you a couple examples from specific ones, but hopefully the conversation is going to be broad enough so that it can apply if you're in a different platform. A conversation earlier about Java, and I don't necessarily have a lot of experience with Java, but a lot of these kinds of things will be able to apply with the Java and Hibernate and some of those areas. It's the same way that we would within Hibernate or Link and the .NET side, right? So we need to be able to translate their stuff from one to the other. A lot of different strategies. One is just hard coding it manually, right? But we might want to use, let's try that again. Here we go. We might want to do a little more complex object structures as well. I mean, the most common one that I see out there is sort of a one-to-one mapping. We have our table, we have our database, our objects, and our objects look identical to our database. Right? You've probably seen that. If you've used any of the tooling, which does scaffolding, for example, and automatically generates one to the other, or in some of the platforms now, they have the ability to generate your database from your models. And so your developer is just coding away happily what their object structures are, and it's just going to say, OK, tool, figure out what the database is going to look like. Any DBAs saw that and choked, right? Because sometimes your developer is creating this really complex object graph. Let's take a look at one, for example, where we have this really great complex object graph where we have billing information, and maybe we have credit card billing is different from a ACH bank billing, and the behaviors are different between the two of those, and so we create this elegant, polymorphic, object-oriented construct, and then generate the database from that, and it's going to be sort of a one-to-one relationship where each part of that database table has a relation with each part of the object structure, which is good object-oriented design. But there might be some problems with this, right? So here we have a billing details table with a credit card table and a bank account table. Notice they all have the same primary key. And so if I wanted to fetch, I get an order, and I want to get my billing information, right? That billing information sometimes is going to be a credit card billing, sometimes it's going to be a bank account billing, right? But we're going to, we don't know until we actually fetch that from the database which one it's going to be. So then we have to create a query like this, which is a really nasty query. We get cross applies and unions and all those kinds of things, and we have to dynamically figure out which column are we pulling from which side, and how are we going to populate that, and how do we handle the nulls on either side. And any DBAs saw this and choked? Yes? Yeah? You don't like that one? I don't like that one either, right? But this is a not uncommon kind of scenario. Performance on this one starts to suffer, right? And how maintainable is it as we start to get transforming across more and more kinds of structures? I had one system that I worked on where they were doing a dynamic form builder. And so we had text boxes as compared to check boxes, as compared to drop-down boxes, as compared to address controls, and all of those are polymorphic behaviors over the other ones. And then so they have a different table for every single one of those, and we're joining out across 20 tables just to get more representation across one thing, which performance was going right down the hill. And it was a system where they could sort of have sections, and a section could have subsections, and then a subsection could have controls. And so you start getting this nesting behavior. Well, when we get a nesting behavior, how do you then map that? Well, we're going to maybe lazy load all those things, which means we're going to have hundreds and hundreds of these really complex queries running against our database just to get one form. Yeah, that one was a fun one to try to fix and rework. Okay, so that's one of the mapping patterns. It's called table per type. Another one we have is table per class. This one, the database structure is a little bit simpler. So we'll have a different table for each one of our concrete class implementations. So everything we need for bank account billing is in one table. Everything we need for credit card billing is in another table. And we're going to have some duplication across these tables. And this is a less normalized version than the first version. The first version is probably the best normalized from a database perspective. But now if we wanted to get the information from both of these, what do we need to do? We need to do a union again, right? And pull these back together so that we can then create our list of, okay, here is the billing for this particular order. And then, you know, our query gets nasty again, right? Here we go. Okay. You know, so it's a similar kind of nasty query. This wasn't so bad as I worked on a system that had a lookup table, or lookup structure. And so lookup might be the key and the value and maybe an active flag and an order indicator, you know, and all of my lookup values had the same structure. And so I wanted to have all of those derived from lookup, right? And so I had a gender lookup, and I had a state lookup, and I had a race lookup, and I had 70-some lookups. And I tried to give that to Entity Framework 1 back in the day, and it then created a query like this, and it was a nested subquery. And SQL Server said, ha! I'm not even going to evaluate that one. I'm just going to throw that back and say, yeah, you got to rework this one. It's not going to work when you have 70 levels deep of a nested correlated subquery, right? So this isn't maybe necessarily the best database performance option either. The simplest one is actually table per hierarchy. And with this one, what we do is we have a discriminator column of some sort, which triggers and says, when I'm accessing this kind of a thing based off of this type value or this active flag or whatever that discriminator is, then hydrate this kind of object, right? Now, the downside of this is if there are properties that are different between each one of those concrete instances, then you need to make sure that those are nullable. And your normalization instructions from college say, no, we're not supposed to have nullable columns in our database. Well, sometimes you have to denormalize things and make them, so that they actually perform, right? Because this query is actually pretty reasonable. Single query, one table, we can filter all those kinds of things down, and life's good, right? Now, oftentimes, like I said, in my data tier, I just sort of have a one-to-one mapping. Now, that doesn't mean that all of the names need to be identical. The column names, we can alias those to what the property names are through a mapping construct, either through convention-based approaches or from a configuration-based approach. Some ORMs use an XML structure to say, here is the mapping from one to another. Some of them use a coding convention that has property assignments and some of those kinds of things. Different ORMs deal with these kinds of things differently. So each ORM is different, but all of them can handle some of these similar kinds of concepts for the larger ones. So we take a step back a little bit and sort of compare from the database world as compared to the object world. We can sort of see that there's a relationship between ORMs and data structures. How many people are using a different database for your transactional approach as compared to your reporting approach, right? It's becoming more and more popular where we have maybe an object-oriented database or a NoSQL kind of database for transactional because it's really fast and we don't have to take the performance hit, and we have eventual consistency maybe in our database for transactional kinds of things. So we're basically storing the object graph of the order details, and everything which we need in that pipeline as one object. But then we might want to do reporting over that in different ways, and that's where we need a relational kind of store or a data warehouse kind of a store for those. And how do we get between the transactional and the reporting systems? We have an ETL, or the mapping, right? So even from a DBA perspective, the ORM kind of paradigm can apply from a database perspective as well, right? So I said there are a bunch of different ORMs, and I'm not going to necessarily say I'm in favor of this one or that one. Each one of them has their pluses and minuses. Some of them are sort of based on the individual language or design philosophies of the languages or platforms and such. Some of the most popular ones out there that I know of from the .NET perspective, Microsoft has Entity Framework. There's Hibernate, which is an open source platform which has been around for a decade at least at this point. So that's based off of Java's Hibernate. There's JDO Objects. There's Spring Data Boot, which is based off on Hibernate as well. From .NET side, there's Dapper. I'll show you a little bit of Dapper. That one's basically you have a SQL statement, and you say, I want this object, go. And it figures out how to create that object. Really performant there. Ruby has Active Record, Data Mapper, and there's other ones out there. And if you're using Python or PHP, or each one of them have different ones. There is a Wikipedia article that has a list of ORMs. It's a little outdated. I sent that list off to my junior millennial developers, and they said, where's this technology? Where's this technology? Where's this technology? And they said, ooh, I can get more bonus points by adding to the Wikipedia article, right? So yeah, that article is a little dated, but it gives you an idea of some of the kinds of platforms that are out there. I'd sort of categorize them into sort of 3 levels. One is what I consider sort of ORM light. Another one is going to be using some sort of specification to be able to configure the query and customize the exact thing that's coming back across the wire. And then one which has an embedded querying language that can actually get more complex operations already built out, so you don't need to build your own specifications. So ORM Lite, this is something like Dapper. Entity Framework has with Entity Framework Core, has a from SQL, which has changed its name a little bit in Core 3. But basically what we have here is the ability to say, we have a connection, I want to run a query, I want that query to return an object of this type, here is the statement, and you can include parameters. So you can have parameterized SQL on these as well. It's not just SQL injection vulnerable. And then run it, and then return the results. Now I can't then, if I wanted to add additional things, if I wanted to change the ordering, if I wanted to add different filtering, if I wanted to put paging on that, I'd need to pass those parameters in to this method, parse those parameters, add dynamically into this SQL statement somehow, the additional things that I need to add in there, and then code in from there, right? It's not built in by default. But there are also techniques to then say, well, I have an enumerable, and I should be able to translate that into a sorted list and then sort from there, and then maybe page all in memory. Downside of that is, of course, I'm now fetching the entire table into memory and then doing my manipulation on the business tier rather than back in the database tier. Depending on how much data you have, if I had millions and millions of rows, that probably wouldn't perform very well if I only wanted 5 rows from a paging perspective, right? So we need to be able to translate the requests in a different way. And that's where the sort of the next phase in here, or the specification pattern, comes into play. In specification pattern, a lot of these patterns were outlined in Martin Fowler's Enterprise Design Patterns book. It's a pretty complex book. There's a lot of things in there. But some of these patterns are really simple and straightforward. For example, a specification pattern, we have a specification that returns Boolean. Is this specification satisfied by this object or this condition? That's all it means, right? So it returns true or false if it's going to meet. And if it meets, then it returns that value. Otherwise, it ignores that value, right? So we can think of a where clause filter, for example, as being a kind of specification. And this is actually the implementation in LINQ of where over objects. And here we have the predicate, which is really our specification. So the predicate then takes an object in and then returns a Boolean true or false whether or not it evaluated properly. So where basically says, as I'm iterating over each row, is this condition met? True? Okay, return that. False? Ignore that, right? If we look sort of the broad level of what where is in that regard. And of course, we can extend these specifications further and further and further. We could have or specifications and specifications that can take a left side and a right side and evaluate whether those are true or not. And we could have a not specification. We can have a where specification. We can have a skip specification. We can have a page specification, page size specification. We can build out all of these various specifications. And some platforms we may need to do those kinds of things because they may not be built for us under the covers already anyway. Or we might be able to leverage a tool that already has some of those kinds of things. The Hibernate world, this is going to be using HQL. Same thing with NHibernate uses HQL. .NET, starting back in 2008, had this technology called Link. I loved it so much, I wrote a book on it. And so with Link, then we can have more and more complex kinds of behaviors and be able to build these more dynamically out. And then if these are queryables, which means it's the definition of the query in an object graph rather than just the result set, then we can then extend that query and add more things to that query dynamically. So in this particular case, I have a customer list that returns an iQueryable of customer list model, which is, so we have our data model, we have our business model, and we don't return our data tier objects, we return our business tier objects directly. And you can use something like AutoMapper to be able to map from one to the other so you don't have to hard code these relationships. In this particular case, it was just as easy for me to set it up directly here. So I could have maybe just the object ID and object name, and then go into some of the child object information and get the orders count, for example, to say, I want to get those that, how many orders have each one of those had? And that's the definition of the query. But then I can extend that. Whoops, it jumped ahead of me here. Here we go. I can extend that to say, well, how about a query that gets me only the active customers? Or the customers that have active orders. I don't want to get all of the orders. I only want the ones that are active that I need to do something about, right? And so maybe we can do those kinds of things. As I'm moving my hand around, my mouse keeps moving here, so apologies there. So we can have those, extend those. We don't have to write our own specification. Basically, the specification is already built for us, right? And be able to build more complex operations. Now, there is debate in terms of how high up the stack do I expose that queryable. Do I expose it all the way up to the UI tier and let the developer figure out how they want to change those kinds of things? Or do I keep that only on the business tier and impose a restriction at that point? Well, oftentimes the UI needs to say, well, I need to change from page 1 to page 2 on my search results, right? And so sometimes it might be beneficial to have that exposed all the way up the stack. Okay. Stop moving around on my mouse here. Maybe I need to turn the mouse off and just do it this way. Stay. Now you've all seen what the rest of the slides are, so I don't need to worry about it, right? Okay. So we can, I personally, I'm a fan, for example, of in .NET, we have services that can expose things via OData, which is a specification through a URL syntax that allows me to change the structure of the query. And that query structure change not only applies in my business tier, but can also be translated all the way down to my database. So that my database is responsible for filtering out the things that I just need, and then optimize that up all the way up the stack. Now, sometimes that can cause performance issues, and so you need to be monitoring those kinds of things and paying attention. And if you're interested in monitoring and paying attention, I recommend you come to my session later in the day where I'm talking about Entity Framework performance tuning. Okay? So a little plug there. So we have these strategies around fetching data. We also need to be aware of, while we're fetching data, there are some anti-patterns to pay attention to. One of the biggest anti-patterns that I've seen has to do with lazy loading, right? Getting these children, so as I get the orders, and I'm iterating through the orders, and then I need to bind the order details, then in lazy loading, it's not going to load the order details unless I need them. But if I know on that page that I'm always going to need the order details, then when I get the order details, if I'm lazy loading, I'm going out to the database and fetching again to get the details for that order. And if I have 5 orders, then I'm going out and I'm doing a n+1 to say, well, I get my orders, and then for each one of those orders, I'm going to get the order details from that separately on each one. And as you get more and more complex, the performance starts to go further and further downhill, right? Particularly with the lazy loading. So that's where I like to do something around eager loading and say, I want to force that every time I get orders, I'm going to get the order details. Now, every time I get customers, I may not get orders, right? It sort of depends on your business domain that you're actually concerning yourself with, and we can isolate those things off in various ways. But if I wanted to get an eager loading representation, I could use include, for example, with Entity Framework, or I could be more customized in exactly what I want to get. And I like to be more customized and say, this is the exact shape of what I want to deal with. And so I could have getting the order, and the order model is different shape from what my order data structure was. The order data structure is more an implementation detail. The order model is what I'm actually going to bind to. And maybe I might want to have a shared object for addresses, for example, that has same behavior across multiple kinds of constructs. And I can then specify, here's the exact columns that I want to get, here's the exact ways that I want to get them. I can then also hydrate in children collections, and I can multiple children collections and grandchildren collections and all those kinds of things, and map all of those in a relatively elegant manner, right? And I'll let the platform translate that to SQL, and I'll review the SQL, make sure that it's acceptable. Sometimes it creates horrendous SQL, sometimes it creates better SQL than what I would have coded myself. Not very often, but it can happen. And so, then we have the ability to say, well, get me that order. And it's going to give me the order plus all of its details. It's going to have the address object, and life's good, right? That usually works. There's sometimes where it doesn't. So if we consider maybe a self-referencing, so we have a employee table that has reports to, and if we wanted to then create the object graph of the entire organizational structure, right? If I would then say, well, get me the employee in all of his reports, and then each one of the reports, all of their reports, each one of those, all of their reports. And if I then told my ORM to, whenever I get the employee, always get the reports under it, then we get a recursive query, right? And it's going to go n levels deep. And heaven forbid we actually, at some point, recurse all the way back to the first one. Just by somebody making a mistake and putting the wrong ID in those kinds of things, right? But one of the strategies that I use sometimes is, let's go ahead and fetch the table, and then do a single pass through that table, and then repoint in that single pass the child of the employees. And so each one of those, each employee can have its all employees or its subordinates. And then I can then say, well, the manager of this one is who the report was. And then, as one final step, I start off and say, give me all the employees that don't have anybody they report to, that's the senior level management, right? And then from senior level management, then I can build the graph of everybody underneath of them in one pass, right? So there are ways of optimizing that to be able to get that in a single request rather than getting it more and more complex. And all these slides, I did upload them to the SQL Pass site this morning, so it might be a little delayed, but you should be able to access those here when you go back home at least, okay? So that's sort of setting the stage. There are a lot of different design patterns that we can then look over. So we have active record, data mapper, repository, domain-driven design, CQRS, unit of work patterns, and some of those kinds of things. Why do we need these patterns? Well, sometimes it's from architectural perspective, just from, we were told in college that we use these design patterns, and so that's the way we're supposed to do things, right? Well, there are pragmatic reasons for that. One is, we already talked about swapping out the database, right? And if I want to be able to swap the database out and not have to change my business tier, my data UI tier, then maybe I should have that abstraction layer, encapsulation, to be able to separate those out so I can make that change. But realize only 2 people in here said they've ever done that, right? So should I over-architect it at this point to say, well, it might happen, and it hardly ever does, in all honesty. Now, a good place for using these patterns is for testability perspective. So if I want to have tests, and I want to have unit tests and integration tests, right? You know the difference between the two of those? A unit test only tests this one function of code. It doesn't touch anything else. So if you are touching your database, you are not writing a unit test, unless you're doing database tests themselves, right? And even so, that might be a little bit hairy. Typically, we would want to do unit tests to say, when the business said this happens, given this state, when this happens, this should be the result. I should have a unit test for that, to prove that that always happens. and then as I make changes to my code, prove that I haven't broken that at all, right? But if I were to do that, and I'm hitting my database, well, A, the performance is going to be a challenge because we're taking that I/O hit going out to the database all the time. And B, the problem with that is our data can change, right? And so if I have a test and I make a change to a data, and the next time I run that test, that data is not what I expected it to be, my test will fail, not because the logic is wrong, but because my data's changed and the data's wrong. So then do I need to go out and every time I run my test suite, I need to hydrate a new, brand new database and then tear that down each time. And there are valid ways for doing that, right? But it does get to be a little more painful. And so if we have a good architectural pattern, then we can maybe abstract out certain layers and then be able to test just individual portions and inject maybe a testing kind of hybrid over top underneath of that to say anytime I'm trying to test a database, then just pretend for the sake of this particular test that these are the values you're going to get, because the values that you're going to get isn't really the logic. That's your beginning state, for example. What you're really testing is, did this calculation work properly, for example, right? So sort of on the flip side of that, some of these architectural questions comes from the Agile world. And the Agile world basically says, don't build it until you need it, right? There's a little term, YAGNI. I don't know if you've heard of YAGNI before. You ain't gonna need it. And so very often in conversations, and somebody says, "Ooh, we could build this really cool, complex structure that does all these kinds of stuff," but they never said that they needed it. And but 10 years from now, this is going to be important. Well, then build it in 10 years, right? Let's build what we can when we need it, and then as we need more things, make sure that what we built was flexible enough that we can then extend that and be able to do other things, right? And so, keep that in mind as we go through some of these patterns and how we're going to separate these things out. So one of the patterns this was really popular probably 10 years ago or so. It's sort of the core of how Ruby worked and accessing databases, and this is active record. And so with active record, each object is responsible for fetching itself, saving itself, and some of those kinds of areas. So we have a person object, which has properties like first name, last name. It has behavior like get exception, is flagged for audit. But it also has, how do I persist myself? How do I get myself? How do I insert myself? How do I update myself, right? And I would say to some extent this is an anti-pattern because we are then leaking the abstraction of the persistence into the object itself, right? So I'm not really a fan of active record. Now some platforms, maybe like Ruby, that's the easiest way of doing things. And if your data model looks exactly like your database model, maybe this is a good option for you. But then we're also probably going to have things like lazy loading that you're going to have to consider in terms of how we're actually fetching those kinds of things. So use that one cautiously, I would say. Instead, I would probably recommend something more along with data mapping. We're talking ORMs, so data mapping, where we have the object, which we're going to persist into a database, and we're going to use some other object, which is going to handle that persistence. The nice thing about this is, if I change my database, I just change my mapper, and I keep my person object intact. I don't have to change and modify that behavior at all, right? This is a good abstraction and isolation between the two of those. Now, on top of that, we may want to have common behavior across multiples of these mappers, and that's where a repository comes into play. And so with a repository, then we can have a generic interface and say that everything that we're accessing in our system is going to have that same behavior of the interface. So each time I want to do a custom, or each time I want to do an order, it's going to have a repository that's going to get, it's going to have insert, it's going to have a delete, it's going to have a way of saving, and getting all, right? And maybe that get all is going to be a queryable, so I could extend that to say, well, don't get all of them from the database. Let me only get those that meet this particular criteria, right? So we have the ability to extend that type of thing. Now, I've seen people that go out and say, well, you should always be using a repository, and you should have a repository over your entity framework models, for example. Anybody do that? Now, the problem with that is consider the entity framework itself is a repository, right? And so if I've gone off and I've coded all of the repositories for this repository, what value have I actually added to my system? Now, sometimes you need that isolation to make sure that your developers aren't doing things that you're not expecting. But I would say maybe a code review would be a better place for that kind of a thing, right? So I'm not necessarily a fan of, if we already have an Hibernate entity framework, and one of those kinds of things, which are in themselves repositories, building a repository on top of the repository. But we might have a religious discussion around that one. Right? So we also might want to, as we get larger and larger systems, split these systems up into multiple subcomponents and not have one context, for example, that spans the entire domain of our database, and have separate contexts for each of the individual components around that. And that's what domain-driven design sort of gets at. With the domain-driven design, we have the concept of an aggregate root and bounded contexts. The aggregate root would be, anytime I access order, I'm also always going to want order details. And so the order is responsible for managing the order details. You don't create a new order detail by itself. You'd use the order to create your order detail record, because there needs to be a tie between the two of those, always. There may not be an aggregate root between customer and order, right? Maybe, maybe not. It sort of depends on what the needs of the application. I can manage customers separately from the orders that that particular customer has. But I may want to have domain constructs around, here's the stuff that my shipping department needs, as compared to here's the stuff that my billing department needs, as compared to here's the stuff that the order process needs, as compared to the management tools, right? And each one of those could have its own bounded context, its own entity framework context, for example, and segregate these things out. Now, there is one caveat to that, in that you can't access across multiple contexts. You can't query across multiple contexts, at least not natively. So if you need to then get information from one to the other, then you sort of need that one's in the middle there, which is sort of a translation between the two of those. For example, in this one, we may have a sales context and a support context. Both of those have customers, both of those have products, but they may be different instances and different behaviors on that one. So it may have two different ones of those kinds of things. This also comes into challenge when we're trying to use something like migrations or code first, where we are creating our code and then basically building our database from our code. And if we have part of the system over in this one, part of it over in this one, part of it over in this one, how do we say, well, generate the SQL for my whole system across these multiple contexts, which may be even different applications, right? So when we start getting into some of the bounded contexts, then we need to maybe not use those elegant, nice little auto mapping kinds of constructs as well. If we take this even a step further, there's a pattern called CQRS, and it's a command query responsibility segregation. Basically what this one says is we're going to have different models and different structures for querying as compared to saving. And it might be different services, could even be different databases from one to the other. And this gives a real abstraction between the two sides of those. But this means that now you probably have double the amount of code that you have to write and maintain as well. Sometimes this is valid, sometimes it's not. Okay? Again, it's sort of a art, it's not a science. And you have to figure out where in your applications do these kinds of things appear. I wanted to sort of point out what some of the concepts are so that you can take that and think about these as you're working through your applications. I sort of use a sort of multi-tier approach where I have my databases, my data structures, I have my business models, which have the behavior in them, and then I have services, which translate between the data structure and the business structure, and then the UI talks to the service, and it gets the business objects, but the UI should never know about the data structures, right? Now, you can have those as physically different libraries, or you could have them all in the same library, and then just sort of have a delineation inside of namespaces or those kinds of things. Sort of depends on how much your developers are observant on exactly how you want to separate these things out. Okay. So there are a lot of then miscellaneous kinds of areas over these patterns. I'm not going to focus too much on some of these. So for example, if we wanted to handle locking, then each one of our objects is fetching data, and we may have one UI that has one set of data, another UI that has another set of the same relational data, and both of them try to save different changes. How do we then deal with the collisions that can occur, right? And probably the most common solution for that is last in wins. So I make a change, you make a change, I save my values, you save your values. Now my changes are gone, right? That's probably not what you want in your transactional system. So then how do you handle that? One way is inside of each of one of your update statements, for example, include in the where clause all of the starting values that you knew about, and then make whatever change you want to make. And then if that where clause fails and doesn't return any rows, then that tells you that somebody else made a change. You need to refresh your values and then make your changes again. But at least you know that there's a problem that you had to deal with. If you don't want to have in your where clause every single column in your database, in your table, which might hurt your performance from an indexing perspective, then you may want to consider adding into your database having a row version column, which basically, from a SQL database perspective, for example, every time you make a change to that row value increments. And so as long as each one of those users that are using your system have the value that they originally fetched, and as long as that value and that ID have not changed between them, we know that I'm good to save, or somebody else has made a change and now we need to make sure we update that. So that second side of that is actually going to give you a little bit better performance from your update perspective, if you want to. But you have to, different platforms are going to require you to code that manually or configure that in different ways. But just be aware that that is one thing you need to deal with. I'm going to skip over the caching strategies. So figure caching has probably been talked about a lot. But I do want to cover a little bit of schema management. There was a number of questions. I came in at the end of Chris. Anybody said Chris Woodruff's session yesterday? Okay, one. There were a number of questions at the end of his session which were dealing with code first and code only and migrations and scaffolding and some of those kinds of things, which is I write the object code and then I allow the database creation or manipulation to happen based off of what I wrote in my code, right? Which is okay if you are the only system that's accessing that database and you have complete control over both sides of the wire, right? If I have multiple systems that are accessing that same database, then each one of those may be adding different things and changing my database in different ways, sometimes conflicting with each other. Same thing with the concurrency issue that we just saw. At that point, what I prefer, the scaffolding and migrations are great for getting started. But once you've gotten started, then I say you should be coding it manually, using maybe a database project to manage your schema, and keep that database project updated with your schema as the database changes, so that you then have the change tracking on what's going on in your database. Use a CI/CD process. So, maybe some of you went to the session right before this one, which was on CI/CD with database projects. If not, you can watch the video around that one to sort of see what you can do with those kinds of things. So the database project, then I can specify, here is what this database should look like. It has only create statements. And then anytime I want to add a column, I'll do it inside of a create statement rather than handwriting my own update statements. And then if I was manually writing my own update statements, then I have to write a rollback script as well to be able to roll that back manually, which becomes really painful. So if I say that this is the state of what it should look like, and then let's use a publish of a DAC pack to then publish that and say, okay, what changes actually need to be made in my script? And I can then generate a script that I can review or apply it directly to the database and have my database managed that way. And then I'll go in and change my code to say, okay, this is what my code should look like as compared to this is what my database looks like. Because personally, I don't think that they should look identical. I think that the objects should have their own behavior and representation, and the physical store have a different one. And you keep those maintained separately. But that allows for us to have good conversations between DBA and developer, making sure we're all doing the right thing at the right time all the time, right? Okay. So, got about 20 minutes left. I wanted to sort of focus on the rest of the time. So, we got these concepts. Well, what do I want you to do about it, right? So I thought it might be good to go through a set of do's and don'ts. These are based off of my experience over 20 years. You may not agree with some of these, so sort of take these with a grain of salt, but it's a good starting point for conversations. So first one, do use the right level of abstraction for your business needs. Don't make sure that you're having abstractions that make sense. But don't over-architect the solution just for the sake of architectural purity, for example, right? Make sure that you're considering exactly what the needs are and how do I separate that out. It is an art. It's not a science. And so making sure that we're figuring out what makes sense for your application. Because if you're writing a management tool, which is forms over data, there's not much business logic whatsoever, you're going to have a very different implementation than if I'm writing a large application that's being used by millions of customers in a web environment that has to scale out across hundreds of servers, right? There's going to be different design decisions that you're going to need to make. You have to have different robustness in those. If I have a mission-critical system that I'm writing for, I was talking with somebody yesterday about trip to the Mars, and I'm needing to have this system that's going to work 60 years into the future in terms of how long it takes to get to Mars, then I'm going to have different design decisions over a system that I write for 3 users that if it fails, they can just stop it and restart it, and there's no problem, right? Stopping and restarting a rocket heading to Mars, that might be a problem. Particularly if it doesn't reboot. Okay, so a couple of those. Objects should be a representation of data and behavior. It's not just, this is the data structure, right? It's, Martin Fowler calls that an anemic object model, where it's just structure and not behavior. You want to have behavior and logic that are associated with those objects to say, this is how this is treated in this domain, and then manage those kinds of things explicitly from there. Don't just have your objects mimic your tables and databases, right? Maybe you don't need all the columns in this particular domain in your object. Then don't populate them, right? Only have what you need in there. But realize also, if I'm not populating some of those columns, when I do my save, I need to make sure that I can handle, for example, on an insert, that those can be null. Because if I don't have that particular property, and I do an insert, it's not going to know how do I populate that particular value, right? But you should separate your data objects from your business models. And this allows you to keep that abstraction layer. This would allow you to inject, for a unit test, the new behavior from the old behavior, right? This allows you to have mocked objects as compared to the actual hitting of the database when I'm doing that. And the shape could be different between the two of those. All depends on what your needs are in your application. I usually don't use the table per hierarchy, table per type, table per class that I was showing you in my data access, but I may use that in my business models and do in my translation between the data and my business, do that translation at that point. Yes, you have to write more code, but oftentimes you can use tooling to say, well, here is my source, and here is the transform that I want to have happen, and then just say, well, generate that from usage, and it'll figure out, okay, here's what the new class is going to look like. Be able to manage it from there. And on the database perspective, to make things easier for ORMs, don't use composite keys, particularly composite keys that have meaning, right? Try to use generic identities, or if you must, a GUID of some sort maybe, But try to use one, because a lot of these tools are expecting sort of a one-to-one, or the relationships are projected sort of under the covers and handled by a convention-based approach. And the convention-based approaches typically don't like composite key relationships. So just make it easier on us to be able to manage it that way. I also recommend to denormalize judiciously. But realize if we're using denormalization, so for example, I've had several situations recently where maybe we have a customer with case notes, and the user wants to see what was the last case note when they opened the customer. And the query that was running to try to figure out across my entire notes table, find what was the last one for each one of those as I'm doing a list of customers, was really causing a big performance problem. Even when I was doing the over statement inside of my SQL database. And so the solution then was, well, on my customer, include a foreign key pointer as last note in there, denormalized. And so then I can do that simple join. I don't need to do all of the order by clauses over the data tables and all those kinds of things, and be able to get that really quickly. But that means also, anytime I add a note to that customer, I need to make sure inside of that transaction to also point to that customer's last note and change the last note on each one of those, right? And it's not going to happen under the covers. You have to explicitly do that as part of that save operation. So when you're doing denormalization, you then have to figure out exactly how am I going to manage that from an object perspective as compared to the relational structure. But performance, I've found a lot of times, is much better if you do that denormalization. So for example, do you really need a state table with a state ID column, and then your address table has a state ID rather than just putting in the state abbreviation, right? Do I need to make that performance hit of that join, or can I have that denormalized? Do I really need gender to be 1 and 2 as compared to male and female? Or yes, there can be other genders as well there too, right? Depending on your business need domain. Okay, the next one, this is almost a hard rule, I would say, at this point. Don't lazy load. Okay? The biggest performance issue I've seen at customers that I've went into is because they were lazy loading 4 levels nested deep of for each loops, and causing all sorts of performance issues. I'll prove that one here later today if you come to the performance talk. Okay. The next one, this is more isolating out of your conceptual models on bigger systems, is consider bounded context and service isolations to be able to give you optimizations, abstractions, and some of those kinds of things. I just find best practices allows unit testing a lot easier. The bounded context perspective, for example, some platforms, Entity Framework 1 through 6 and .NET, for example, if we had this huge, if we basically did generate the EDMX from the database, and we had 200 tables in our database, that EDMX got really big. And then the first time we ran our application, it went really slow because it had to reprocess everything that was inside of that EDMX to figure out all of the mapping structures that were going inside of that. Whereas if I separated that off into bounded context, and I had one context that had 20 tables, one context that had 5 tables, one context that had 20 tables, and separate contexts of each of those, the performance was a lot faster for processing each one of those individually rather than this big monolithic construct of my data structures. So it sort of depends on your models and those kinds of things. You should have unit tests and integration tests for your business requirements. That doesn't mean that I am not a I don't require you to have 100% code coverage. I actually find that 100% code coverage sometimes to be an anti-pattern. Do you really need testing over, does my object relational mapping system work? Or do I trust that I can translate my data structures over to my data tier, and I don't need coverage over my data tier, but I do need coverage over those behaviors inside of my business tier, right? And then if we're going to do that, then I need to be able to have unit tests that can test that. But I also think you should have integration tests to prove that, yes, this really complex query does return the kinds of things that you're expecting it to from the database itself. Because if I'm mocking out the database, and the translation to the database is actually the problem, which it can be sometimes, is that query generation really the performance hit, you should have that built in there. Additionally, if you have really a good set of integration tests, you can, one, do a profile and send that profile, if you're not the DBA, send the profile to the DBA of these are the kinds of things that I'm doing in my system. Could you review them and tell me which ones of these we need to change, right? And two, I can then monitor performance around that one so that every time I run my tests, I can find, oh, this particular method, it used to take 10 milliseconds and is now taking 2 minutes. Maybe we need to go back and address and see what changed inside of the behavior of this one now, rather than waiting a month from now to figure out all of the different changes that have happened over that month to try to figure out where that happened. If I can find that within that day, it's going to be much easier to figure out exactly what the code change was that caused that problem at that point rather than waiting later, right? So lots of benefits to having instead of integration tests in addition to the unit tests. And maybe you're only going to run the integration tests when you actually check into the source repository and have your unit tests before you're checking to the repository. So it depends on your needs and your applications at that point. We got ORMs. They're great tools, but there are times where they're not. And so don't force yourself to using the ORM for 100% of your application when that 10% of reporting, let's say, was going to be better with another tool, right? Or maybe I'll use Entity Framework for some parts of it and Dapper for other parts of it. And pick and choose the right tool for the right job at the right time. And also make sure that you're profiling your generated SQL. Often the biggest performance issue that I've seen is not necessarily because the tool does the wrong things, because the developers did the wrong thing with the tool, right? And so you need to be paying attention. If you're not paying attention, you're probably going to do things that you didn't know. And sometimes even what worked before, now we upgrade to a new version of something, and that changed the behavior under the covers, and you might need to pay attention to see, okay, so now we have a problem over here where it used to work before over there. And that's just because the SQL generation changed. If anybody's using Entity Framework Core, for example, Core 2 to Core 3, the queries are much different going to the database. In certain cases, you may find that you're hitting runtime errors in Core 3 that we're working with Core 2. And so you need to make sure that you're paying attention and watching what's going on. Lots of ways of doing that. Again, I'll cover some of those later today. And then sort of the last one that I'll sort of leave you with is, should I use ETL or ORMs for ETL? No. Probably the number one issue that I've seen in terms of people saying, well, ORMs suck. And actually, anybody wearing the badge that has the little tag, ORMs suck, on it? I think there's some actually out there here today. When I hear ORMs suck, it's because they're saying, and in Stack Overflow articles, they say, well, I was going out and I was trying to insert 1 million records into my database using Entity Framework, and the performance was just horrendous. Well, you're using the wrong tool. You shouldn't be using Entity Framework to insert 1 million rows, right? If you're trying to insert 1 million rows using Entity Framework, how many requests to the database is that going to be? 1 million. That's probably not going to be the best option. Similarly, if I wanted to give everybody in my company a 5% raise, do I need to go out and download over the wire into my business tier all 100,000 or however many employees that you have records, update the values, and then issue 100,000 requests off to the database, as compared to issuing a single update statement, right? So figure out what's the right tool for the right job at the right time. Hopefully, I've given you food to think about. And did anybody not agree with something that I said? I can't believe that. Okay, one person. Thank you for being honest. I appreciate that. Like I said, we're talking about this. We're talking about these are my opinions, which may not agree with your opinions, which may not agree with our domains may be different, right? And so maybe we have different things which we need to consider based off of our individual needs. And that's where we can have, sometimes the conversations are the most important part, right? And so I would love to, after the session, let's grab a drink or get lunch or whatever, and let's argue about it at that point, right? Because sometimes there are things which, maybe I'm not doing things right myself. We can always improve. But hopefully I've given you, a lot of basis to think about. Feel free to, maybe instead of slamming me in the surveys themselves, have an individual conversation, right? And so we can then deal with these individually. So, food for thought. Again, the slides should be up on the SQL Pass site as soon as they get published. I uploaded them earlier today. My contact information, my Twitter alias at Jim Wooley, my email address, jimw@slalom. I have a bunch of different presentations. The GitHub links down here are actually from my performance talk that's later today. So if you're not able to make that, you can check that out. But as you probably saw from my slides, you can't necessarily glean exactly what I'm saying until you come to the presentation. So hopefully you've got some good ideas and food for thought, and it's made you think about things in slightly different ways today. And if so, then my job has been fulfilled. Otherwise, come up and let's have a conversation. Are there any questions for the broad community before I let you guys go, though? Yes, sir.
On the topic of forcing ORMs, would you say it might be fair to say for simple CRUD-like statements and processes use the ORM, but for complex query polls, maybe use a store procedure instead?
Okay. And for those that are on the recording feed, the question is it a fair statement to say that ORMs are great for standard CRUD, and then for more complex querying, use maybe a different tool for complex kinds of operations and such? It sort of depends, right? I can write a fairly complex query, which is fairly performant in LINQ, for example, to be able to do certain things. I don't want to write a dynamic query that does that, right? So if I need dynamic querying, I don't think that a ORM should be a reporting tool, right? But if we're building things where we need to fetch things into memory, manipulate the stuff in memory, and then persist information again, that's a really good place for ORMs, right? So it could go beyond just simple CRUD. But yeah, there is a breaking point which you need to figure out exactly where those kinds of things are. And sometimes go ahead and write it in there and then find, well, this is where performance issue is. Let me go ahead and just change that one thing. Because we don't necessarily want to over-optimize our code ahead of time. Let's get the implementation done, and now let's figure out where do we need to then consider things as well. But don't just assume that, okay, it worked on my database, my developer database that has 300 rows in it, as compared to my production database that has 3 million rows in it. And you might get different behavior between the two of those, right? So your database platforms should be able to mimic each other in certain ways to give a good representation to know, yeah, we might have a problem. And oftentimes your developer database should have like 5 times the amount of information that your production database is, because your production is going to grow over time, and you want to anticipate the needs in the future as well, right? But yeah, good question. Okay, anything else? No. Thanks everybody for coming out. I hope I see you later in this afternoon. Otherwise, have a great day and enjoy the rest of the conference. Thank you.